In this lesson, we are going to discuss momentum and impulse. At the end of this video lesson, you should be able to define momentum and impulse and perform calculations involving momentum and impulse. Let us first define momentum. Momentum is the measure of one's motion. It is denoted by the symbol P. Suppose we have a car going to the right and a truck going to the left. There are two important components used to measure one's motion. First is the mass, which describes how much object is moving. In this case, the car has a mass of 2,000 kilograms and the truck has a mass of 20,000 kilograms. The second component is the velocity, which describes how fast the object is moving. In this case, the car and the truck have a velocity of positive 10 meters per second and negative 10 meters per second respectively. Take note that they are moving at the same pace or velocity but at different directions as indicated by the sign. The positive sign means left to right motion, while the negative sign means right to left motion. Since it is important to take note of the direction of the velocity, it also affects momentum. Thus, momentum follows the direction of the object's velocity. This gives negative p for the truck and positive p for the car. To compute for momentum, we multiply the mass and velocity of the moving object. Thus, we have p is equal to m times v, in which p is momentum, m is mass, and v is velocity. This will give a unit of kilograms meter per second. In this case, the truck has a momentum of negative 200,000 kilogram meter per second, and the car has a momentum of 20,000 kilogram meter per second. Suppose there is a collision that happened. The truck can now cause the car to move because of the exerted force. This is what we call impulse. It is defined as the force from an object which causes another object to move at a time interval. It is described by the formula I is equal to the force multiplied to delta t, or change in time. We can also define impulse as the change in momentum of an object. In this case, we need to write it in terms of change in p. To do this, we need to use Newton's second law of motion. From this, we can write acceleration as the change in velocity per change in time. Multiplying the change in time on both sides of the equation, we will have f times delta t is equal to m times delta v. With this equation, we can now write the equation in terms of I. Since I is equal to f times change in time as described in the previous part, we have I is equal to m times change in velocity. We can expand the change in velocity as the final velocity minus initial velocity. Distributing the mass to both velocities, we have I is equal to mass times final velocity minus mass times initial velocity. We know that momentum is the product of the mass and velocity of an object. Thus, we have impulse is equal to the final momentum minus initial momentum. Finally, we can write the change in momentum using delta. Thus, we have impulse is equal to delta p, or the change in momentum. Take note that we may use any of the formulas here depending on the available data. Let us now try solving a problem involving impulse. Suppose a truck hits a 1,000 kilogram car giving it a speed of 5 meters per second. What impulse does it impart to the car? Let us identify the given quantities in this problem. First, we have the mass of the car, which is 1,000 kilograms. Its change in velocity is 5 meters per second. Lastly, we are looking for impulse. Since the only available quantities are mass and velocity, and since we are looking for impulse, we can use the formula for impulse in terms of mass and velocity, which is I is equal to mass times delta v. Plugging in the values, we have impulse is equal to 1,000 kilograms times 5 meters per second. Thus, the impulse is equal to 5,000 kilograms meter per second. Suppose the truck had contact with the car for 2 seconds. How much force caused the movement of the car? Let us identify the given quantities for this problem. First, we already know that impulse is 5,000 kilograms meter per second. Second, the statement mentions time, which is 2 seconds. We are asked to compute for the force exerted by the truck onto the car. We can use the formula of impulse by definition, which is I is equal to f times change in time. To solve for force, we need to isolate f by dividing both sides of the equation by delta t. Thus, we have f is equal to I over delta t. Plugging in the values, we have 5,000 kilograms meter per second all over 2 seconds. We cannot cancel any unit here, so we will have force is equal to 2,500 newtons or kilograms meter per second squared. Let us now review the following key points. First, momentum is the measure of one's motion. Second, impulse is the force from an object which causes another object to move at a time interval. And lastly, Newton's second law of motion provides different ways on how to solve problems on momentum and impulse. And that ends our discussion on momentum and impulse.